A company is buying AA batteries in bulk, and they want to make sure that the batteries that they're buying is around 2500 milliampere hours on the average. So it tests 20 batteries, and this is the data it received. Okay, so the mean value is 2505.35, and if you take the difference squares of these data, of data minus the mean value of this data, this 2505.35, then it gets this following value. And the question is to find the confidence interval of the mean milliampere hours of the batteries with 95% confidence level. All right, so we should first recall the formula, which is that the x bar minus e is the lower bound for the population mean, and x bar plus e is the upper bound for the population mean, with e being equal to the z alpha over 2 of sigma divided by, not sigma in this case. Well, let me write down the formula in general and then modify it. So this is the error bound if the population standard deviation sigma is known, and if it's known. But in our case, the population sigma is not given, so we can't use this formula. And especially, so first we have to replace the sigma by Sx, the Bessel corrected standard deviation, and then square root of n. And then more importantly, because this number 20 is less than 30, if your data set is less than 30, instead of the z alpha over 2, you need to use the CNT distribution. So you have to use t alpha over 2. Okay, so we will try to compute this one by one. So first, what is Sx? Well, Sx is the sum of xi minus x bar squared, but you divide it not by n, which is what you would do if you just wanted the standard deviation of the given data, but here we have to divide by n minus 1, the Bessel correction, and then you have to take the square root, because inside this square root is what we call the variance, and you have to take the square root of the variance to get Sx. Okay, so let's try to do this. So in our case, it should be 225144.55 divided by 20 minus 1, which is 19. Let's put that into the calculator. So we want square root of 225144.55 divided by 19, enter, and that's 108.85. Okay, 108.85. Okay, now we have to figure out t alpha over 2. To get t alpha over 2, you first need to think about what this 95 confidence level means. Well, that means 0.95 is equals to 1 minus alpha, the alpha value, where alpha would be 0.05 then, and alpha over 2 would be 0.025. And what you need to do is to get t alpha over 2, it's the inverse t in your calculator of 1 minus alpha over 2 value. Okay, so this is the formula you have to use, and it should be second vars. Go down to inverse t, enter, and you put 1 minus alpha over 2 is 0.025. Oh, and then there's something else I forgot to say. The degree of freedom is n minus 1. Okay, so df is defined for the CNT distribution. The degree of freedom is defined as n minus 1. df has other meanings, but for CNT distribution, we'll just remember it as n minus 1. And for later cases, I'll explain what that means. All right, so going back, we have to put 19, because 20 minus 1 is 19, and if we paste we get the value of 2.093. Okay, so we see that t alpha over 2 is 2.093. And now we have almost everything that we need. We have E equals to 2.093 times 108.85 divided by square root of n, which is 20. Let's put that into the calculator and see what that gives us. Let's move it over here so I can easily copy. So 2.093 times 108.85, and then you divide by the square root of 20, enter, and 50.94. Okay, so we have 50.94. And therefore, because, well, I guess we still need to compute x bar minus c, that's going to be 2505.35. That's the sample mean minus the 50.94. And we should also do the 2505.35 plus 50.94. And those are the two values, 2454.41, 2454.41. And x bar plus e is 2556.29, and therefore the answer would be, so the answer is that the population mean is between those two values, 2556.29 and 2454.41. Okay, related question is, right now we can measure the accuracy of the population mean to plus or minus 50.94. But if the company is not so sure, it wants to make sure of the population mean within plus minus 10, how many samples should it require? And for that, we just start with the formula that we were given, this one right here, right? We take that and we solve for n. So E is equal to z alpha over 2 sigma over square root of n, where sigma can be replaced by the Bessel corrected sample mean, because if you don't have access to the sigma. In a lot of cases that happens, okay? So we solve this for e by multiplying by square root of n and dividing by e and taking the square of it. You get n equals to z alpha over 2 sigma over e, and the entire thing is squared. So that requires we find z alpha over 2, and there will be inverse norm of 1 minus alpha over 2. So let's do that. Second bars, inverse norm, enter, and you need 1 minus 0.025, and if I do that, it's 1.96 most likely. Okay, so that's going to be 1.96. And then sigma, we had the value, right? We had the value which was 108.85. So let's write that down. So sigma is about same as the Sx, which is 108.85. And then E is, we want the error not to be more than 10. So in our case, it will be 1.96 times sigma is 108.85, and then we divide it by 10, which is the desired accuracy, and then we square it. So let's apply that to a calculator. So 1.96 times 108.85 divided by 10. And then we need to square this, so I'm going to put square. And we have to round up. That's another important thing. You have to round up the answer. So 456 batteries. So equals 455 point something something. So round up. And you get 456 batteries. That's how much you have to test in order to nail down the mean value of the population within plus minus 10 milliampere hours with the accuracy of 95%. No, with the confidence level of 95%. Okay. Now here's another question. You want to rent an unfurnished one-bedroom apartment in Boston next year. The mean monthly rent for a simple random sample of 25 apartments advertised in the local newspaper is $2,100, and the standard deviation is known. So actually, this is the important part. The standard deviation is known, and whenever you're trying to judge the population mean, and your sample size is only 25, so 25 is less than 30, right? In that case, you might ask, do we need t-distribution? But here, no, because we are given the sample mean, not the population standard deviation, population standard deviation, which is in our case is 220. Okay, so we just go with z alpha over 2. Okay, all right. So z alpha over 2 is inverse norm of 1 minus alpha over 2. The confidence level 99% means that alpha is 0.01, and you have to divide that by 2, right? Because our alpha is 0.01. Okay. So let's figure this out. Second vars, and we have inverse norm of, instead of 1 minus 0.025, we'll do, well, let's clear this and say 1 minus 0.01 divided by 2. Okay, so we use this, and that gives us 2.576. Okay, so 2.576. Okay, and oh, I should have explained why I want this, because the reason I want this is because the population mean is at minimum x bar minus e, and at most x bar plus e, and the basic formula for the error is that z alpha over 2 sigma over square root of n, where sigma has to be replaced with sx if you don't have the population standard deviation, and also z alpha over 2 has to be replaced by t alpha over 2 if you're not given the population standard deviation nor the sample size is more than 30 or more. Okay, so if we weren't given this 220, and if it was said that our sample had this standard deviation of something, then you will need to change this into Sx, and then change this z alpha over 2 to be t alpha over 2, because our sample size is only 25. Okay. All right. So, but this is what we need for this context, and we have 2.576 times 220 and divided by square root of 25. That's because that's the sample size, right? Okay. Now let's put that in here. Square root of 25 is 5, so that knowing that would make it easier for us. 2.576 times 220, and then we'll just divide by 5, which is the square root of 25. and 113.344 is what we have. So this is 113.24, is it? Yeah, no, 344. Okay, so we'll just go with 34. And then now we know what x bar minus E is. That's 2100 minus 113.34, and that's going to be 1986 point, I guess 66. Okay, and x bar plus E would be 2100 plus 113.34, which would be 2213.34, and that makes the answer would be that the housing price would be the average housing price. We know with 95% confidence level it's between these two numbers.